morning, ninth grade. I wonder how you made out with your quadratic equations. I wish I had the answer key to help you, to show you the answers. I wish all of you had an answer key. Then you could check your own work. Yeah. So I am going to give you just a couple of answers here this morning. We did a number of the problems yesterday, but I'm going to give you a couple answers this morning because it's important. And I didn't do 1 and 2, so I will give you those answers this morning. You should be over here on the right hand side of the page. 1 is there, the answer is right there, and then number 2's answer is there, and then number 4's answer is here. I think we did 3. And then in the back of the lesson, you should have had a couple more there. Let me see if I can find those. Yeah, I don't know. Did you do 20? Here we go, 22. Let me see, it should have been, find the quadrant, it's 36 and 37. Maybe you want some answers here. Let me do you 22. You need to do 22. I don't know if you did that one. There's 22's answer. 22's answer there by my finger. Here is 23. Where's 24? There we go. 24. I know you can still skip a couple of those. Maybe you need the graph. How you like that little thin line there? Does that look like yours? And there you can maybe see a couple more answers, And check what you can. We're going to get back here to 36 here pretty soon. Here we go. 36 answer should look like right here. Right here by my finger. And oh, there's a story problem. Yeah, oh yeah. You want to get that one. That's 35's answer. Let me see if I can turn the page and get you 37. 37 should be right there. 37's answer. 38's answer is there. 39. I don't know. Did you do 40? There you go. You got a few more again today, so work on those. And we're going to do lesson 9.12 is what I'm going to have, and it's talking about the domain of an equation as well as a function of it. And I put it over here on the side of the board, 9.13, just kind of on the side. So 8.13, sorry. At 8.13, a unit back, we had a function. And if you remember, no, you go back there. I'm not going to go back and explain the function to you, but I think if you go back and look at that lesson, it'll come back to you. You had to decide if something was a function or not. And you would use that same ratio. Well, maybe I should just talk about it because it connects so much with today's lesson. Remember that if a line, whether it was a function or not, you could not have the same, like if you had a 3 and a 5 in a set, and then you had a 2 and a 6, that would work. But then if you would put the 3, the x value, if you would ascribe it to another one, if this here term right here would be ascribed to a different on a y-axis, it could not be a function. And so then you had different examples of how that would be if you had a line here with I'll just do it like that there. And if you could draw a straight upright line through and hit 2 points, it was not a function. You go back and look at that to just brief you up on what was a function. So today, when we talk about the domain of something, we are again like adding to your understanding of a function. So the domain is something is a range, would be a good way to say it, or another way to say it. It's the domain of the x-axis, okay? The x-axis. So whenever you have a set of numbers like you do right here, and you want to know the domain of, and I can even add here, I need to change this here at the end. I can't have a 7 there, I'm going to make this at a 9. And so you can plot them, you can do whatever you want to with them, as long as you have a line on your graph. It's the domain, it's the x-axis. So I don't like this marker. And get one that I can use better. So let me just talk about this here a little bit. It's, let's say for instance, I come over here and I have a domain. Whoa! That guy gave up the ghost. He doesn't write it. That was my favorite black marker. He had a cap on it. So what went wrong? Well, I'll tell you what, I'm getting out of markers. You know what? I'm writing a lot more on chalkboard when you're not here than when you're here. I guess when you're here, I use my mouth and talk, and now I have to write everything on the chalkboard so you can see. So if the domain is there, and let's say it's over here, so the domain is, let's see here, I forgot to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is number 9 here, and this is 1, 2, 3, 4, 5. This is 5 negative. So the domain, you can't see that hardly, can you? The domain is from 5 negative to 9 positive. That's the domain, the range of it. Now if you make a line here, and you got some of these here, and you got arrows like it there, that means the domain goes from unending, any real number. You know, it's unending, so you can't put a stopping point. But if you have the dots, let's say for instance, I would put the dots. This marker's shot, I hate this. Let's go right here. I put the dot right there at -1, and I'm going to put it on a slope down like this. I don't know where I got that urge. But I go from here, and I draw it down to here. The domain is going to be from -1, and we got 1, 2, 3, 4, 5 positive. Okay? So the domain is between -1 and 5 positive. You always check the x-axis. Now you can put a whole bunch of them out here. You can put a dot there. You've got some examples like this. You can put a dot there. You can put a dot here, and then you can put a dot. Oh yeah, let's go over here, and yeah, you can put it in numerous places here. You can keep going, and any of those are the domain. So if you was to write the domain, it's not connected by any lines, okay? I just put dots, just plotted points on a graph. So because it's not connected by any dots, all you need is just count this pot. So I'm gonna say this one is 5 negative, this one is 3 negative. I'm not sure if I'm right or not. This one is 3, and this one is about 7. I don't know if that's right. I just put numbers there at the graph. So my domain for this number is -3, -5. I got specific numbers of what it is. It can never be a 0. Okay? Lesson will tell you that. You can never have a 0. And so when you look at your functions, if you turn over, we will do the first problem. Read your instructions. Look at your example 2 on page 454. And then we're ready to do number 1. You're going to specify the dominion and tell whether or not it represents a function. Okay, we'll get the dominion, and then we're going to find say yes or no for a function. Okay, so you get the dominion. It's a 2. You know the next one, a 3. You know the next one, a 4. You see what I'm doing? Do you see how to do this? Look at your lesson. If you don't know, look at your examples. But it's the first one, just like right here. It's the first one in your set. So in this one here, be 3, 2, 3. So I'm looking at number 1. I got 2. It's the first one. The next one is a 3. It's your x-axis. Then the next one is 4. The next one is 5. There's your answer. So does it move? Does it work as a function? Yes, sure does. Okay. Now number 2. You tell me. You tell me whether that you have y equals 4x plus 7. Is that let me see, what is dominion or the domain? Okay, you look at the X. What's the X stand for? The X is, well, I don't know. Any number you would want to put in there would equal Y. So your answer is any real number. You couldn't put 0 there, not 0, but any real number. So I could put a 1 in there. I could put a 2 in there. I could even put a -3 in there. Any real number is your answer. And so, let me ask you, is it a function? Oh, sure is. You're right. Yes, it is. Number 3. Now you got the graphs. And let me see, you got a circle. So here, I got started here with the circle here. Let me see if I can just finish this circle. This is that's your graph. Is that got, what's your domain? Do you have a domain? Sure do. You have to look in the book. What is your first number? It is going to be a -3. Okay, and then it's going to go over to +2. So -3, +2. I want you to take a little bit of a note how you write that. The way they do is negative. Am I looking at this right? Yes, -3. And it stops at 3. So it can be 3x to 2. 2. Positive. That would be your answer. That's your domain of that circle on number 3. -3 to +2, and that's the way you would write it. Yeah, let me ask you now, is it a function? Well, if you would draw a line through it, could you touch 2 of them at one time? Sure could. According to 8.13, what you were taught in that lesson, it cannot be a function. No. You ready for number 4? There you have 3 as your domain. You just simply, I'm going to use this part of the thing, it's just a straight line. It's on 3 though. It's actually over here on 3. So your domain is 3. That's all it is. You got to be on the 3. 1, 2, 3, which I'm not counting 3 here, okay? So don't go where I drew it, but I'm just giving you an example. And does it have a function? What did you learn in 8.13? Can you draw a line across it? Well, you know, can you draw a straight up line? Well, you can draw it right on it, but it's still 3. So that answer is no again. It is not a function. Now you got number 5. Am I going to do all these? I don't know about that one. Yeah, I guess I do. I'm doing number 5. So you got the V. So, what is your domain? Well, you see those arrows? It's unending. I mean, they're going out off the graph as far as humanity can think, I guess. So it's any or all real numbers, any real number, or a real number, or however you want to put it, any number. And is it a function? By now you've caught on, it sure is. Let's look at number 6 yet, and then I'm going to let you go. And there's some at the back of the book that you'll get practice on, and I'm sure you'll get practice on the next couple of days as well. Number 6, you got some dots. You got a point here, a plot there. So you find those numbers, and I'll just help you out. The one at the top on the right is a 1. But the one on the left at the top of your graph is a 1, 2, 3 negative. And so you just simply put the numbers that those plots are. That's your domain. And then you ask the question, is it a function? Okay, is it a function? Are there any 2 dots that are right on top of each other? No, there's not. So yes, number 6, your answer is yes, it is a function. Have fun, and I will see you tomorrow.